So we've been using Tactair components in our boat, predominantly around the rake system, and it's been very impressive to see the progression that we've made. I think when you get new components, you have to use them and understand what you want. And what I've been so impressed about is we've been able to give really good feedback on what we're actually looking for. And then every time we get a new iteration, the boat just gets better and better.
For an aircraft, we're typically trying to design a valve that will last many cycles, many years, for hundreds of thousands of cycles. When we're designing for Artemis Racing, it only needs to last for a couple of thousand cycles, so we can get much more aggressive in our weight reduction efforts. Because we are so aggressive with our weight reduction efforts, we have to be very careful that we still meet the structural intent of the design as we're trying to look for weight-saving opportunities.
Well, weight's kind of everything in these boats. It's probably the #1 factor that we focus on in the design and execution of them. So the lighter our systems are, the faster the boat will go. Simple as that. So we do as much as we can to structurally optimize the hydraulic components for the pressure they operate at.
In the aerospace industry, we're typically designing to 3,000 to 5,000 psi operating pressures. Artemis will run predominantly at 5,000 psi, and we're using the same materials, same aerospace quality aluminums, same aerospace materials for both industries. So the challenge becomes making those materials and those structures meet the requirements and meet those higher operating pressures.
These boats are airplanes in my mind. They have wings, they have all the same characteristics, flight surfaces, and properties of an aircraft. It's just kind of turned upside down and put in the water. And that's what's kind of cool about it, is we can apply a lot of aviation models and know-how to these boats, and it works right out of the box. That's how close they are.